All right, for these problems, we're going to take just two generic functions. So I have the function of f of x is equal to 8x minus 9, and g of x is equal to the square root of 2x minus 1. I want to find these functions and state their domain. So if I'm looking at these values, then I want to find the domain of each. So the domain of my f of x function, now remember there are two big fat no-nos when it comes to domain, a negative under an even root and a 0 in the denominator. For this instance, we don't really have a radical, for this f of x, we don't have a denominator and we don't have to worry about having an even root. We just simply look at this and say, okay, this one's kind of a free-for-all. So my domain for this function is going to be from negative infinity to positive infinity. However, for that g of x function, take a look. Because I have a radical, I'm going to have to determine when is 2x minus 1 greater than or equal to 0, because that's the smallest number before I get a negative. And then solve it. Add 1 to both sides and you get 2x is greater than or equal to 1. Divide by 2 and x is greater than or equal to 1/2. So you can express that domain from 1/2 to infinity. Cool. So when you're looking at your composition of function, it has to work for both. It has to work for both domains when you get to the domain part. Cool. So first of all, let's just put these two guys together. I have my f of x function. So I have 8x minus 9 plus my square root of 2x minus 1. Now, is there anything I can do to combine those two functions? No. The only way you can combine a radical is how? Exact same radical, and then you add the coefficients. Good. That's not the case here, so we're done. And if the domain has to work for both of them, if I look at this domain, my first one is negative to positive infinity, so that's a free-for-all. I don't have to worry about that. But my second domain has to go from 1/2 to infinity. Cool, right? Yeah, let's try another one. Okay, we already found the domains of each of these functions, so we're just going to keep that on there. But now I want to do f minus g of x. So if I have f minus g of x, when you're going through and you're looking at this problem, we're going to take our 8x minus 9 and subtract the square root of 2x minus 1. Again, is there anything I can do to combine those? Nope. And when you look at your domain has to account for both problems. So again, because f of x is negative to positive infinity, the domain of this composition is going to go from 1/2 to infinity. Pretty cool, right? It's not so bad. You look at these problems and think you've got a lot going on because of the square root in there, but honestly, it's not a big deal. If you can add and subtract, certainly we can multiply and divide. So if I have f times g of x, I have 8x minus 9 times the square root of 2x minus 1. And you cannot FOIL, you cannot work that through because of that radical symbol. It just is what it is. And then our domain, just like our other two, are going to end up being from 1/2 to infinity. And that's just because the only restrictions we have are on that second one. Super easy, right? Cool, let's do one more. We add, subtract, multiply. Let's do a little division. Okay, so let's divide this out. Again, we know the domain of 8x minus 9 is infinities, and our g of x function is 1/2 to infinity. So let's do some division. I end up with 8x minus 9 over the square root of 2x minus 1. Now for this particular problem, we're not going to worry about rationalizing the denominator or messing with that at all. Just keep the denominator as a radical. It's no big deal. We'll go with that. The biggest issue is not only do I have a radical, but where is that radical? In the denominator. So my radical, my domain is 1/2 to infinity, but in the denominator is 1/2 an option for me? No. So how do I readjust that domain? Good. You have parenthesis from 1/2 to infinity. Bracket, because if it was in the numerator, such as every other problem we've been doing, it's no big deal. But in the denominator, 1/2 cannot be a solution because that is the value that makes it 0. So you can't have a 0 in the denominator. So this is kind of like a double whammy for domain. So there it is. Not too bad, right? Cool.